Hello everybody. So today we're going to be covering another round of our DMD questions, and we are going to be looking at our week 5, day 2 on inclusion and exclusion. So basically for this chapter, we're going to be focusing on a couple of details. So firstly, how to draw a basic Venn diagram to go and explain, and how to go and put all of the information into a simple diagram to observe. How to understand a Venn diagram once it's being drawn, and also how to draw a special line graph that is used mainly for our inclusion and exclusion. Then last but not least, as usual, to practice a question. So let's think about how to express, how to even draw a Venn diagram first. So we're actually, in a Venn diagram here, we're trying to explain some key points using just certain circles. And let's say we have this question here. 50 students join tuition. 30 students join English tuition, while 20 students join math tuition. 5 students join both math and English tuition. Now, it's okay. Probably this question is still going to be easy for many of us to go and observe. But if let's say the question gets more complicated and there are more things that are being factored inside, it's going to be a little bit harder to do. So in this case, we can draw a Venn diagram here to explain. In this rectangle here, this consists of all 50 students that we're talking about that joined the tuition. But not all of them actually join or like all types of tuition. Some of them only join English. Some of them join only math. Now, the thing is, the size of the circles here, of course, it will be better if it's proportionate to them, to the sizes here, but it's not very important. What's more important is the values that is inside here. Now, we want to say that all 30 students join the English tuition, which means the entire circle here is 30. While for math, it would be 20. However, we notice there are some overlapping sections in the middle. So these overlapping sections here, they have their own values too. And that's the reason why, in this case, we cannot just write a simple 30 inside here like that. Because this 30, does it represent the full circle? Does it represent just part of the circle? We cannot exactly tell if we just did it like that. So the best way to actually represent our values is to start first from the middle, to go and draw your circles ready. Starting from the middle, 5 students join both math and English tuition. We write the 5 here. From the 30 students, since we know 5 of them actually joined the math tuition or the English tuition already, we can subtract away the 5, putting 25 here. Now we know this 25 only represents this section of the Venn diagram. Same for the other side as well. 20 students join math. 5 of them are in the middle. We subtract 5, we're left with 15 at the side. However, adding up all these values, 25, 15, and 5 only gives us 45. Because there are some students that actually didn't join tuition. Although it's not specifically mentioned, but we can infer. And this is your basic method in actually drawing our Venn diagram. Writing this 30 and 20 here, it will be considered as optional. But if you do feel that it's actually helpful for us to go and use this information later, you can consider doing so. Now, how do we learn how to determine the values inside the diagrams? Because some questions could come a little bit more complicated, like a typical place value sort of question, or in this case, probably even the word divisibility, factors and multiples, just like what we have learned in the previous video. So between numbers 1 to 50, how many numbers are a multiple of 3, 5, or both? So what we are looking at is to see numbers that are a multiple of 3 and numbers that are also a multiple of 5, because they say or both, right? Smack in the middle. So in this case here, we actually see, this is how we can observe our Venn diagrams, and we know that we want these values. However, how do we solve them? We can solve them in a more special way. Let's look at 3 over here. How do we find out how many numbers are a multiple of 3? We know that, okay, every time we actually see a multiple of 3, it'll be 3, 6, 9, 12. It happens once every 3 numbers, starting from the number 1. So out of the 50 numbers that are present, what we can do is to divide by 3 to give us here, if we write down 16R2. However, if you really think about it, the remainder is not important. So what we can do over here is to firstly erase the remainder and write it in a special way with this special bracket. This bracket over here basically tells you to go and write the quotient, not the remainder. So we know that there are 16 numbers here. At the same time, if we did it to the same For 5, we will have gotten 10. We know there are 10 numbers here. However, we also know that there are some numbers that actually fit both criteria. And the only way you can actually fit both criteria is if you are a multiple of 15. So that's why in this case, we also do the same for 15 as well. Doing the calculations will give us 3. And that's where we can start to put in numbers. 3, and if there's 16 in the whole circle, we get 13 on the left-hand side. 10 minus 3, we get 7 on the right. And now, if the question was asking for not a multiple of 3, 5, or both, we can figure out the outside parts as well. However, since we're only focused on the inside region, all we need to do is to add 13 plus 3 plus 7. We get the answer 23. Now, there's a special method that actually I would like to share with all of you, which is how to draw a line graph. A line graph actually also plays a part in helping us to go and observe your inclusion and exclusion graph, but it's something that is actually not really taught that often. But I personally feel it's actually still quite helpful, hence I'm sharing for everybody here. Now, a line graph can actually help you determine your maximum or minimum overlaps pretty easily. And let me give you an example that looks very similar to something that we had from early on. Now, 50 students join tuition, 35 students join English tuition, while 20 students join math tuition. What's the minimum number of students that join both tuitions? So if we notice from the previous question, right? Okay, so if let's say we want to have, let's say the question didn't ask you for minimum, but for maximum, we actually find it very easy where we can put all 20 students here that join math tuition must have joined English. But what if it's the minimum number? Basically trying to force some overlaps in between. Now, from the previous Venn diagram, we probably can find some ways. However, I want to show you this method here, which can make it a little easier for us to observe. So with 2 lines, we can actually draw an arrow on the left-hand side that actually represents the English. These represents 35 students, which fair enough, it does not meet all of the people. Now, if we add in the 20 math tuitions, the students that join the math tuitions, we want to find the minimum number of students that join both. Hence, I want to have as little overlap as possible. You notice on the right-hand side, there's so much space. All these students haven't been stated to have joined tuition. So we add another double arrow there. This allows us to show our 20 students that join the math tuition. So what about the overlap? We know that there is some overlap in between. And when you overlap in between, this means that you have joined both tuitions. So 35, 20, you'll be wondering, so wait, how much is the overlap here? Now, you know that if you added 35 and 20, it will have given you 55 students, which now this is definitely more than the number of students that join tuition. So the overlap has to be 55 minus 50 to give us 5. So you can mark it out this portion and you figure out the value that is 5. Now, let me also just further give you the chance to go and visualize this. Observe this 35. This 35 stretch. And like I said, because you want to minimize the overlap, that's why we only take the non-overlapping section. We know that this whole section, the blue colored lines on both sides add up together to give us 50. So that's why the excess over here is then subsequently counted, subtracted, and then deemed to be 5. So now let us learn how to apply the techniques that we have over here into our NMOS question. So there are 30 pupils in my class. 20 pupils like math and 18 pupils here like English. Now, as there are double the number of students that actually like both subjects as compared to those who like neither. So how many pupils only like math? Now, there is an interesting condition here, which they tell you twice as many pupils like both subjects, while those as compared to those who like neither. Now, in this case over here, it's going to be a little bit difficult for us to be able to identify since we're not given a value. But not to worry, let us try to go and put the values inside our Venn diagram. So in our Venn diagram over here, I've drawn a very simple one, or at least I've animated the simple one. We're going to put that these students like math and these students like English. There is supposed to be 20 students here, while there are supposed to be 18 students. Issue is, I am not sure of the number of students that like both or those students who like neither. So I can use a little bit of algebra. This I can label as X. And since those that like the both subjects here is twice as many, we're going to label this as 2X. Let's put in the values. 2X. Those that like math, only 20 minus 2X. Those that like English, only 18 minus 2X. Then on the outside, those that like neither, just X. If we notice again, adding all 1, 2, 3, 4 values here gives us the total number of pupils. So we add them together. 20 minus 2X plus 2X. And for very obvious reasons, we already noticed this will give us 0 because it represents the full circle. Now, without adding the overlap again, plus 18 minus 2X plus X, and this gives us 30. So from here, after we do some simple simplifications, 38 minus X gives us 30, where X equals to 8. What's the last thing we have to do? How many pupils only like math? We notice it's only on this left-hand region. So 20 minus 2X, 20 minus 2 times 8, and it gives us the final answer of 4. Again, although improportionate, but it doesn't really matter because as long as we can still solve the question in the end. So last but not least, for the DMD as well, please remember to go and complete all 3 questions. Please remember to send your answers inside the group chat and also to take note of the solutions that will be sent out as well. Thank you, everybody.